off in the last video, we'll start off with our bolt detailing and fabrication options. In here, we can set the bolt designation shown on details and the bolt designation shown in reports of SDS2. Just like our material callouts, we can set this option to bolt material only or bolt material and type. So I can call it out as just A325, or I can call it out as A325NX, or whatever the actual name of the material is, instead of just the grade or the material of the bolt. Where do I want my field bolts listed on? Do I want them listed with the supported member or the supporting member? In this image you can see the field bolts are attached to the beam here, and this member line is a column. If I attach it to supporting, it'll be with the column, so when it turns the stick they'll go away. And if I turn it to supported, it'll be attached to the beam. Plot field bolt bill of material information. So do I want to actually plot the field bolt information? Otherwise it'll just show the field bolt information on the detail. Summarize field bolt list and bill of material. This gives you a field bolt summary on the member detail itself. Include unit quantities and weights for field bolts in the bill of material. Summarize like field bolts on details. This gives you a field bolt note on the detail itself. This can be combined with or without the option for the bill of material. List washers and secondary nut with field bolts on details. So I can list any sort of secondary nuts and or washers. Summarize like shop bolts on details. So I can give a shop bolt summarization at below the title. List washers and secondary nuts. And the bolt summary format, do I want unit quantity, total quantity, or unit and total? So in this one I have 3 beams with 4 per beam. I have 3 beams with a total of 12, and 3 beams with 4 per beam with a total of 12 listed. For my bolt callout, do I want to include units of measure? You can see the inches here. And do I want to include DIA or the diameter symbol or none in my callouts?
You can see there's the same for your nut callouts and for your washer callouts.
And lastly, bolt nut washer broken out in BOM is new to 2020. Do you want the individual parts of the bolt, the nuts and the washers all listed in their separate lines or not? Connection detailing fabrication options. This allows us to define the default stability angle size. Do I want to show field bolted stability angles on column, on beam, or ship loose? If I ship it loose, they will not be displayed in the model or in the bill of material. I also have the information for safety erection seats. So if I'm using a safety seat, I can define the angle size, whether I want that safety erection seat connection to the supporting to be bolted or welded, the attached long leg if there's an angle leg here that's long leg, supported or supporting, the gauge on leg to supported and the gauge on leg to supporting, what is my distance, and the gap for safety seat at bottom flange, what do I want my gap to be. We also have an option for use backing bar for pre-qualified welds, and do weld prep on moment flange plates. If I have a bolted moment flange, I can check this and it'll provide the preps on that flange automatically. At the bottom down here in our bolt detailing options, we have information that we can set per bolt size. We can specify the default bolt spacing, what tension control tool type to be used for that bolt size, large or small. This is if you're using a TC bolt. Like in your washer criteria, if you set the bolt type to TC, or if you're using F1852, we make a tension control gun check to make sure you can get a gun on a TC bolt to snap it off. Do you want the large gun or the small gun to be used? And then on top of that, you have control over specifically the values for those guns. These values are pulled directly from the AIC manual. Member detailing fabrication options. This is going to have information that will affect your model. So modifying information in here will affect some results of the model that you'll need to go back and reprocess everything to update or have it set ahead of time prior to modeling. To start off with, we'll start with beams. What do we want our preferred bottom flange view style as? A cross section or a worm's eye view? Provide minimum cope depth. This will ignore the K of the member it's framing into and provide you with a minimum cope. And what is your minimum clearance for your cope? The minimum distance for the cope radius center clearance from face of flange. This is how far down from the bottom of the top flange is this radius center. Reasons you might want this is to provide an overall deeper cope. Some CNC machines cannot cut extremely shallow copes because of the shank of the head of the machines. So using a deeper cope allows the machines to cut the copes more efficiently on the CNC machines. Round cope length to nearest. What do you want your length of your copes rounded to? This is a fractional precision. You can round from 0.1 to 2 inches. And the round cope depth. The cope radius value. What do you want your cope radius to be for your beam copes? And the cope cut type. Do you want it perpendicular to the web? Or do you want it to be parallel to the flange? Round off material length where possible. This affects only your clip angle and bent plate connection types. It rounds off the right end of the beam material to round to the nearest quarter inch. So it can actually round up or down to the nearest quarter inch for the beam length itself. That gives you a different setback on the right ends or material clearance on the right ends on these connections if this is checked on. Your member end edge distance. This is the distance from the end of the beam back to where the row of holes are for your connections. For standard connections, this is typically 2 times the bolt diameter minimum by the AISC. This is a minimum value, so if you have a larger bolt that requires larger edge distances, we will up that value to make sure we meet our minimums. When you have a sloping member, do you want to square cut the end of it or not? This only works to a certain degree. At a certain point, the slope is too extreme to make it square cut, so we will bevel it at a certain point. And the same for spliced members. Do you want your beams detailed in position or horizontal? Show design loads on details. You can have it show design loads for none, only for input design loads, or all design loads. Input would be anything that you physically put in there, like this moment load is not auto, it is input by the user. Input loads would only show the moment load that was input, and all loads gives you the entire end reactions on the member details. Show member quantities and member numbers. This shows the member numbers and or quantities of members with the values filled out for that piece mark. And the capacity load. This is actually the design capacity loads for the connection. Same with the show member quantities and member numbers. Do you want to show grid notes on member details? For beams, this will give you the grids that these beams are on. Show end elevations on details. Do you want to show which elevations this beam is on if they're on multiple? And it'll have a quantity in here. End elevation reference point. Do you want that elevation reference point put at the end of the material or at the work point of the stick line? And add work point dimensions. This adds a dimension to that work point from the end of the beam here. And lastly, show camber on bill of material. Do you want to include the bill of material camber note in your remarks? If this member was cambered, do you want to include it in the remarks column here? And you can specify what the prefix of that callout is. By default, it's just C equals. For your columns, preferred base plate view orientation, worm's eye or bird's eye. Again, top-down section type cut or from the bottom up. Show face C on details, as required always or never. And the same thing with face A. These are your 2 flanges from your web near side view. Annotate faces of pipe details, so you'll get a note of face B, which is the main face. Do you want to show that on a pipe detail or not? What do you want the default end cut for the columns at base plates to be. You can have mill cut or square cut called out. Show erection pinholes. Do you want erection pinholes put in by default for your columns? And you can control whether or not these erection pinholes are CNC downloadable, the erection pinhole diameter, and the vertical edge distance of the hole. And do you want your columns detailed in position, always vertical or always horizontal? Show design loads on details, same options as your beams. And the same thing for the show capacity loads on details. Show grid notes on details, none, one, or all. You can list what grids these columns are at. And show end elevations on details. You can have the none or the first column. Top elevation reference point. Do you want the elevation called out here at the main material or at the work point elevation? Show sections framing into column. This gives you the section and the size framing into the column here for these flange hole connections or shear tab connections. Your HSS notch radius for through shear plates. Do you want to auto calculate the radius, or you can specify the exact radius? If it's 0, it'll be square cuts. Anything larger than the actual width will provide a circular hole at the end. Your total notch width clearance. This puts half the clearance on either side. For your vertical braces, you have the option to locate by default all vertical braces on the neutral axis as opposed to the gauge line. You have your minimum member and edge distance. For your gusset to supporting member, do you want it welded or bolted with a clip angle? Detailed in position or horizontal. Show design loads on details and show capacity loads on details. For your HSS welded connections, how many erection bolts do you want? None, one, or two. And the hole type for HSS erection bolts. Do you want standard round, short slot, long slot, or oversized? This is the hole size in the gusset for that welded connection. HSS notch radius. What do you want your notch radius to be? You have auto, or you can specify a physical radius. Your total notch width clearance. This is the total clearance, so half on either side. HSS double paddle clearance. Welded angle end weld. Do you want a weld at the end of the welded angle here to a gusset plate? And welded angle balanced welds. And then what is your minimum web stiffener thickness? So when you're designing into the web here and we need a web stiffener, what is your minimum thickness to use? For the clip angle connection of gusset to supporting member, do you want it welded or bolted to the gusset? What clip angle size do you want? Which side do you want to attach the long leg to? The supported, which is the gusset and brace, or the supporting, which is the column? What hole types do you want used to supported and to supporting? What is the gauge on supporting member? So you can specify a standard gauge or leave it 0, and it'll adjust the gauges as needed in each situation. What is the gauge on supported member? The gauge to the connection on the gusset. And do you want to stagger bolts or not? And use expanded bolt spacing. And there's an option to allow reduced edge distance for 7/8 bolts and 1-inch bolts. This would allow for slightly smaller angle sizes. For horizontal braces, a lot of these are the same. So you have neutral axis or the gauge line, you have your member and edge distances, you have your gusset to single beam connection, welded or clip angle, detailed in position or horizontal, your design loads on details and capacity loads on details, show grid notes on details, your default back-to-back angle stitch plate gap. What is your default gap that you want? Initially, the defaults are 0, so there is no stitch plates on back-to-back horizontal braces. There's an option to allow material work line offset. This will be if you're framing into the bottom of the flange, the gusset has to frame to the bottom, so then it'll allow the material to be offset down from the member line to allow for this situation. And if you're using the welded option for your HSS horizontal braces, do you want none, 1, or 2 for the erection bolts? And the hole types for the gusset in that case. And again, your HSS double paddle clearance. And for the welded angle end welds for your angle braces, welded to the gusset. And again, for your welded, do you want balanced welds or not? And your minimum web stiffener for your horizontal braces. And on your clip angle connection of gusset to supporting member, do you want welded to gusset or bolted to gusset? And the default gusset clips on both sides, near side or far side. Your clip angle size. The attached long leg to. Your hole types to supported and supporting. Your double gauge on supporting member. And your single gauge on supporting member. And what do you want that gauge measured from? The center line of the gusset or from the back of the angle? Gauge on supported member, which is the distance on the gusset plate. Do you want to stagger bolts in those connections or not? Allow reduced edge distances. And what is the distance from the clip to gusset dimension? What is that distance there? For handrail, there's only a few options. Do you want to have the elevation noted either top of the rail, center of the rail, or not noted on your handrail details? And for the elevation at the bottom of the post as well. For stairs, you can set your preferred auxiliary view orientation from either the inside or the outside. The inside would be considered more like a bookend, where you have both stringers opened up, running in different directions. The outsides just give you the same view at different points. One from the outside of the stringer, and the main one, which is always from the inside of that stringer. For new stair stringer length on BOM and detail, do you want that by default set to pre-cut or post-cut? You can see a difference here of the lengths for that stringer. What length do you want called out by default for the bill information for that stringer? And we already looked at our stitch plate once, but we have the ability for the type of spacer for double bracing. Bolted ring, bolted plate, or welded plate. When you have a welded option where it's welding to a T-stem, do you want it bolted ring, plate, or welded plate? What is the max allowed stitch plate spacing? If you have one, otherwise you can leave it auto. You can specify the minimum number of stitch plates allowed, the max stitch plate extension beyond brace, and the stitch plate width. For miscellaneous, we have the option to detail in position, horizontal, or vertical. These are for our miscellaneous members. And for our grading and grading treads, we can add the bearing bar thickness to the description in the BOM for grading. This is often a requirement in some MRP softwares like FabSuite or Tekla EPM. Tension-only braces we looked at when we brought up our rod bracing. We have the length of bottom rod for rod bracing. This is the first rod here from the lowest end. The length of rod brace thread. The gap between rod braces at turnbuckle. What pin type do you want to use in the clevis? Member isolation defaults. These are your default view depths for all the different member types for the main views created in modeling when you were processing and to detail the member with. What this does is if SDS2 decides that it needs a top flange view for any reason, it will either auto define the depth in and out, or you can specify what depth you want it to always use for the top view. This does not tell to always use a top flange view for every member, but when a top flange view is used for a beam in this case, what do you want the in and out of that depth to be at that top flange? So you can limit how far in and out of the screen you see from the top flange for that top flange view. and this is true for any of the member types here that are listed on the tabs. Material isolation presets are the same, but for all the different material types, when the system creates a system view, what depths do you want used for those views? Detailing annotation and dimensioning defaults. These are your member detailing options, which we'll dig into more deeply once we get to our detailing of our members, group members, and submaterials. But essentially, this sets the defaults for all members, group members, and submaterials that are added to the model. This is what is stored initially to those members for your detailing options. Once detailed, these options are saved with the drawing specifically, but this affects any newly created or newly modeled members from the start. This is also true with your detail erection view defaults. This is your default erection view detailing options. So for any new view created, these are the default values set on those views. Once detailed, they are saved with that drawing, and once, if changed, are only affecting that single drawing or any drawing selected at the time. We'll talk more about that with the detailing here shortly. Our non-standard field bolts on erection view details allows you to specify information to call out non-standard field bolts in that view. You have the ability to specify a specific label format with %S and any designation to separate or have extra annotations to these $S's, and every single one of these $S's will be the item up here in the order you pick. So in this case, there's 3 items, so we have 3 %S's with a dash, a quote, and square brackets. So the end result of this would be the quantity with a dash, the diameter with an inch sign, and a square bracket with the bolt material type, and you can close bracket. You also have a match table where it'll call out a symbol for any field bolts on that view. So you have the ability for the object style to be just a quantity, a diamond shape, or a hexagon shape. The quantity format for that can be specified with whatever prefix with $S. So you can see here 3 different examples. The symbol is the letter or option used in that prefix, and then the diameter you can set as the diameter of the actual bolt and type of bolt, and whether or not to include quantity. In this case, this list can be filled out with non-standard field bolts. Any specialty bolt sizes or types or information needs to be provided. And when detailing your erection view, there's a checkbox to annotate your non-standard field bolts, where it'll go through and apply these 2 tables and provide that information. Anything that's not in the match table will have a label provided for it as defined up at the top here. Member label configuration allows you to specify how you want your member labels in your model to show up. For instance, you can have the property name. This is the options for the piece marks, section sizes, left and right end elevation that you see in the model, as well as any custom property information that you set can be included in here. And you can set the perspective, lengthwise or cross-section of when this is visible, and a specific horizontal position and vertical position. So if you needed to modify the location you wanted your piece marks on the right end versus the left end, you can specify that in your member label configuration. Detailing symbol options allows you to specify the bevel symbol base dimension, so whatever you want the base out of. Do you want to show the bevel angle degrees on the bevel symbol? Combine weld symbols. Do you want multiple welds called out or a single weld symbol with multiple leaders? And then there's a couple options here to allow weld symbol to be drawn on material. Do you want this to be drawn on the material or always keep it off the material? Use pre-qualified weld tail text by default. This allows the pre-qualified weld tail text to be added automatically for welds you add. Add weld leader cranks. Do you want a crank to be always added or as needed? Allow the hole symbol to be drawn on materials. Again, do you want these to be allowed on the materials or always kept off of the material? Allow piece marks to be drawn on the material. Show paint stripe on framing side of shear plates. This is the paint stripe for showing which side is the framing face of your shear tab. Show non-standard hole sizes on detail drawings. This calls out the non-standard hole sizes. The show non-quad boundary slot rotations. Basically, anything that's not a 0 or a 90 will be called out with an angle on it. Call out standard holes with mixed bolt hole units on details. This gives you the option to call out your mixed holes and bolts. And your designation for non-standard holes, do you want them clouded with a pointer or just a pointer that goes to a dimension running through those holes? And then lastly, an option to cloud and note holes having slip critical bolts. This will cloud and put a note. However you would like to fill out here, you have 3 lines. It will cloud and note those holes as having slip critical. Some galvanizing options. In the general tab, you have your kettle defaults. This is used for some of your galv reports to know which members may or may not fit in the galvanizing kettles if you have that information. The connections tab allows you to set the bolt finish, either mechanically galvanized or hot dipped, when the member is checked galvanized. You have the option to automatically break apart galvanized members. So if I check galvanized on a member, it automatically checks on break apart, which ships all bolted materials as its own member. I can specify the surface finish for when galvanized is checked for my materials. I have the default vent drain hole diameters. This affects your handrail options when it provides the vent and drain holes. I can add a galvanizing duplex coating label to the remarks column of the BOM. This adds galv in the remarks or not. And I can add a note that says no chromate quench when members are marked as galvanized. And lastly, I can cloud and note vent drain holes on member details. So this will cloud and note them as vent drain holes. That's it for the basics of the Fabricator setup. Again, you'll want to make sure that this is all set ahead of time. Some of these options do affect your modeling results. A lot of these affect just the detail output, but anything essentially with the Fabricator options next to it here, for the detailing and fabrication options, those will have items in there that could potentially affect your modeling output. So you want to make sure that any changes in these that you reprocess, and any other changes you need to at least redetail the drawings if you have details already created.